Okay, I was looking over this a little bit, and I went a little bit fast here. This 1 plus or minus 2. 1 minus 2 is minus 1, but this 1 should have been 3 is the other answer. So 1 plus 2 is equal to 3. I wanted to reuse this example and say some more about it. So I wanted to do the quadratic formula. So the example that I just did, all the steps were correct, and I just, very last step, it should have been 1 plus or minus 2, and then 1 minus 2 is minus 1, 1 plus 2 is positive 3. All right, so what I want to do now is the quadratic formula. And the hardest part about the quadratic formula is memorizing it. Maybe the second hardest part about it is not forgetting about standard form. All right, so those are the two hardest things with the quadratic formula: remembering it and then not forgetting to put it in standard form. And the coolest thing about the quadratic formula actually is that you can actually sing it to the tune of Pop Goes the Weasel. There might be some other tunes that work, but that's the one I know of. It's pretty funny if you think about it for a minute. But yeah, so let me warm up my throat a little bit, get my best singing voice. All right, so here goes. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, there it is. Usually I would only do that once the whole semester, but now it's on the internet forever, and you can rewind it and hear it as many times as you like. But I think once is probably plenty, unless you're weird. But anyway, let's do it. So here, we already saw the solutions are 3 and negative 1 because, well, if it were already completed the square, the answer would jump out that way. But the cool thing about math is that if there's more than one way to solve the problem, you always are going to get the same answer. Unless one of the methods is known to produce extraneous solutions, but let's see what we get here. So there's actually, there's more than one way to look at this. So I'll just do it the way it's written first. So let's solve this. Well, now we're in the quadratic formula. So we got Pop Goes the Weasel, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So double negative, this one is 6, plus or minus double negative, so negative 6 times negative 6 is a positive 36. And this is also there's only 2 negatives on this one, so we get plus, I think that, what does that end up being? 68 or something? Yeah, those numbers aren't that big, but let me do it anyway. I think it's 80 something. 108, right. Yeah, so we're supposed to get a whole number for the answer. This is going to be like 144, I think, yeah. Well, 144 is actually 12. So we get either 18/6 or we get -6/6, which is also known as +3 or -1. So yeah, that checks out. And maybe solution 2. Here's a reasonable question, and yes, this is totally valid. Multiply both sides by 1/3 because there's a common factor here. Oh, sorry, I didn't copy it. There we go. So it's x squared minus 2x minus 3 is equal to 0. Well, now it depends on the instructions. Did I tell you to use the quadratic formula? Then you have to use the quadratic formula. Well, maybe this one you can factor it pretty quickly. So maybe solution 2, I'll do it by factoring because I didn't give special instructions here. X plus 3 equals 0, which means, x minus 3 is equal to 0, which means x is equal to +3. X plus 1 is equal to 0, means x is equal to -1. Solution set is -1 and +3 once again. Well, solution 3, we take this here, we have, it's in standard form. Let's take a moment to appreciate that C is, well, here, if we divided both sides by 3, it's the quadratic formula again, but all the numbers are smaller, so this should be a lot easier. So x is -b plus or minus square root of b squared minus 4 times a times c all over 2a. So 2 plus or minus the square root of 4 plus 12 all over 2. So 2 plus or minus square root 16 all over 2. So that's 2 plus or minus 4 all over 2. So that's either, yeah, so anyways. Same thing over and over again, so that's fine. All right, so since it's an online class, there's not going to be any question at all about whether or not you can have a formula sheet or not. I would never try to enforce that in this kind of situation. I mean, knowing how to use it is kind of the important thing, and yeah, memorizing is a little bit annoying, but there's a whole song and everything, so it's not a big deal. Actually, let's stay on this side of the board. Let's just keep that here. Let's just erase everything else. So let's just do one where the numbers are a little different. All right, so let's
want to deal with a couple of different situations, and then I want to talk about the discriminant. So let's. All right, so let me just pick a few out of here. Okay. Yeah, all right, so let's do. Yeah, let's do those, and then let's see. Yeah, okay, let's just do those. So I want to. Yeah, so if there are a few different things going on here. Let's do this one first. So just. So problem A, 2x squared plus 3x plus 8 is equal to 0. Let me remind you that I could have written the problem this way, and then you'd have. Maybe I'm kind of beating the dead horse, but this is a really easy mistake to make. That's not standard form. It's not all the numbers on one side and then 0 on the other side. It's very, very, the quadratic formula only assumes that you've written in this form, or else A, B, and C are not these. It has to be like this, or else A, B, and C have to refer to exactly those things. So anyway, now we can do it. So x is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let me just get the calculator now, because I can do this in my head. I just don't necessarily trust myself to get it right. That's going to be 64 though. That's just 8 times 8, right? Yeah. All right, so and then that's going to be negative. Okay, so both solutions involve taking the square root of a negative number here, so let's just point that out here. And there is no real number that you can square to get negative 55. So that's what this thing is right here. So and there's two ways that we commonly write the empty set. One is that we write, it's like set notation. We write the beginning of the set with like the these curly brackets, and then let's put a list of all the solutions inside of there, and then we close it. And well, here they are. There are none of them. There's nothing. It's just an empty box with nothing inside of it. It's the empty set, and there's a symbol specific for representing the same concept. Just a 0 with a diagonal line through it. And those are the real solutions. If you believe in imaginary numbers, well, imaginary numbers have a lot of applications in some situations, but if you're asking how many, how many donuts do I have to buy to make everybody happy? And well, they don't sell imaginary donuts anywhere in real life, so for that particular setting, it would mean you're out of luck. There's no way to actually attain that in real life. So, so for now, we just leave it at that. So if we know that we're in a context where only real values make sense for what we're trying to interpret, then we're done here. This equation has no real number solutions, and that's it. So what happens if instead it's letter B? So again, x is negative b plus or minus the square root of b squared minus 4 times a times, now c is negative 8 all over 2 times a. So we get negative 3 plus or minus the square root of 9. Now it's a double negative, so it's plus 64 all over 4. Negative 3 plus or minus the square root of 73 all over 4. Okay, so square root of 73. 73 is that a prime number? I think it's a prime number. Yeah. Yeah, 72 is composite, but 73. So we leave it like that. So comma, so we write down one solution, the one that has a plus, then we write the solution that has a minus before the square root part, and we get two different solutions here. And so we can look at that for a minute. Bring it forward maybe a little bit. All right, and then let's do this last one. Now this one, maybe you've already factored it. Just depends on what method I tell you to use, or if I give you free choice. I'm going to do the quadratic formula because there's like a moral to the story, and sort of there's some, there's also this set I was going to talk about the discriminant, which is also what I'm trying to get at here. So letter C, let's just use the quadratic formula. So this x is negative b plus or minus square root of b squared minus 4a is equal to 1. C is positive 9 all over 2a. You get 6 plus or minus square root of 36 minus, so that's pretty funny, but that's square root of 0 is, well, so you distribute that 1/2. Well, what happens when you add or subtract 0? You get, well, this technically in set theory we don't like this. We don't say the same. It's 3 is either an element of our set or not. There isn't, in set theory, there isn't really, the fact that it's there twice is of no relevance. So let's not write it funny, and let's write it the normal way. But yeah, this is kind of curious. I really encourage you to experiment with this one a little bit, see what happens. What happens if you graph it, even with a graphing calculator, or you just take sample points, and what happens if you factor it. So all of these things, there's a lot of interesting things that happen when you only get one solution, and they're all, maybe you should pause right now and spend, like, 5 or 10 minutes doing these things. Well, what do we graph? Let's just let f of x be the left-hand side of the equation. We want to see what are the zeros. Let's let, y or f of x. So we can try graphing. Well, the original problem was, when is that equal to 0? We call that a function f, or y equals f of x has a graph of some sort, and that graph reaches 0 for some x values. It happens only at x equals 3. But at any rate, what I want to talk about next is the discriminant. So I can do that right here. Usually they call us capital D for discriminant. And it's just well, is everything you need to know about how many solutions, and are they real or are they imaginary? All that information is right here. So just look at the quadratic formula, and the quadratic formula tells you what's going to happen. Because here are the solutions. They might be real numbers, they might not be real numbers. And there might be just one solution, or there might be multiple solutions. So the most typical one for applications is if the discriminant is bigger than 0. This one is extra special. D equals 0 is a very, very special case. If D is equal to 0, then it's just like the one we just did. Then this thing that we plus or minus in the numerator is just 0. You plus or minus 0, it has no impact whatsoever. So then D is equal to 0 exactly. There's exactly one real solution, and solve this one as well. If d is less than 0, what happens? D is the thing you have to take the square root of. If you have to take the square root of a negative number, so just in case you go on to the next math class, that'd be a good thing. I don't want to contradict whatever your next professor is going to tell you. What I'm saying is there's no real solution. If you go on, and we're not going to do imaginary numbers here. They're not super duper hard, but hey, one thing at a time. If there were solutions, well, the real numbers aren't a big enough number system. You would need some kind of square root of -1 to make everything magically work. And it turns out that this is something that you can do, but there are some issues you have to deal with, a few things you have to learn. A lot of it's the same, but a lot of it is also different, and just one step at a time. And from the point of view of, how many donuts do I have to buy it to make everybody happy? If I have to buy an imaginary number of donuts, then that's not a thing that I can ever do in real life. You can't buy imaginary donuts at Dunkin' Donuts. You're just out of luck because you don't have that option available to you. That option has no physical interpretation in your situation, and for a lot of applications into mathematics, if you see d is negative, it means the physical thing that you've just described just cannot be solved in real life. So, and that's a perfectly valid way of looking at it for those situations. And that's it for now. The real challenge is going to be completing the square. So I actually made it be worth double points because it's kind of a pain, but you'll have 2 weekends to work on it. I already posted that. It's just you have to actually do it, and there's a few different steps, and you just do it slowly, one step at a time, and completing the square is kind of annoying, but you can do it. You just have to it's just a thing, and you'll be rewarded for it when you do. So that's it.